very much. I want to say not only is it wonderful that the RI is back open, that this is also the first public talk I've managed to do since 2019, so it's wonderful for me as
That
well.
big.
And we're looking tonight at patterns,
That might be
specifically
next
patterns
Oh no.
that help us understand and explain what
Vietnamese.
goes on in the universe. Specifically, the 10 that I've picked out are listed here, and I'm just going to highlight some of them. Now, I have to confess, I'm actually only going to talk about 6 of them in any great detail. The book this is based on has 10 in, but if I'd gone through all 10, you would have very tiny little bits on each one. I wanted to have a little bit more time on each one. So if you really want to go to the Royal Institution afterwards and ask for 40% of your admission fee back, you can look for a negotiation, but I hope you won't decide that's a good idea.
A lot of different
So the 10
types
I'll
of
be covering,
uniforms.
the ones I'll be speaking about tonight are the ones in yellow. Before we actually look at those patterns, I think there's 2 things we need to think about. One's science. This is the Royal Institution, so we ought to be thinking about science. And all the patterns in this book, all the patterns I'll be talking about tonight, are patterns involved in science. Now, according to my dictionary, this is my dictionary definition of science, it's the systematic study of the structure and behavior of the physical and natural world through observation and experiment. And I think you can go as far as to say, if there were not patterns,
If this
there
were
would
a
not be
petri
science.
dish.
If, for instance, every time you go and measure something, it's different. Every
Jay
time
Fauci.
you look at the night sky, it's totally different.
Bill Gates
Everything you
chart.
do
Right.
is totally different. It's chaos. There is no pattern. There can be no science. There can be no
Wow.
explanation. Science is built
Organization,
on patterns.
theory,
Now,
chaos,
when they
invert square.
sort of put me on
there,
hold
but
before I came in here,
it has the same
they
uniform.
rather dangerously put me in the Royal Institution Library, which is a wonderful selection of books, and I was browsing through it and actually found a fascinating book called Puzzles, Problems and Enigmas by John Zyman, who was a physicist at Bristol University. And he makes a really nice little comment. He says, "Science is to be believed because it can be openly criticized. The criterion for belief is not authority nor logical necessity, but nobody has yet found a more convincing pattern of interpretation. Science is all about finding the most convincing pattern of interpretation for what we observe and discover in experiments." So, he's said this for me, really. There are many patterns in science, thousands of patterns in science that I could have covered. And whenever you,
Could get
if you like,
Ewing
produce a
value,
list of things,
Minkowski in space,
inevitably people say,
Copenhagen
"Why didn't you talk about this pattern?
interpretation,
Why didn't you talk about this?" or whatever.
Bell's equality,
These are
exclusion,
not, I'm not claiming these are the best ever, 10
bosonic and
best ever science
fermonic,
patterns that you
whether
might
it
get in a Channel 4
starts to
TV
come
program.
into focus for you,
I'm not
and you
even
can
going to say
value
they're
the
the most
calculation in that
important
field.
patterns in science. They're 10 that I found really interesting myself,
Yeah,
and I hope in
yeah.
sharing some of those with you, you'll find them interesting too. So, I think hopefully you're all happy with the concept that patterns are important to science. But I guess there's one lower level issue here. What is a pattern in the first place? What are patterns? The fact is patterns are essential, not just in science, but for our interaction
This
with
is how
the world
to,
around us.
I don't
If
know,
we
make
had to
Noah's
learn
Ark,
how
right?
to operate every single light switch individually, we would never get on
Just
in
keep
life.
moving
But
here.
luckily, there's a broad pattern. I know if I put my finger on the light switch and press down, I will turn the light on, unless I'm in America and I discovered they put the light switches on the wall upside down. But that's a part. I know the pattern of light switches. I know how to switch the light on. I don't have to learn it every time. Those patterns are crucial. And obviously, historically and in an evolutionary sense, patterns have been with us for a long way because they are about survival. We look
For
for
the boys in the
patterns
middle, this is
naturally.
like regular ones
You
they've been
look
eating
for
for
the
them.
pattern of
Bounty and rabbit.
a predator
said you
in the
would go on it.
bushes. Is that a tiger out there coming to get me? You look for the pattern of food if you're searching for
Well.
food, if you're foraging. And we are
Well.
particularly good at recognizing the pattern of human faces. Faces are incredibly important patterns to us and obviously
Especially
important
this
to the
guy down
survival
here.
of the species.
Danger Dave.
So much so that we're actually really good at fooling ourselves. We're very good at, for instance, seeing patterns that
It's your
just
first time
aren't
in the middle.
there. This is a classic example, photograph some of you may have seen in the past. It's a photograph of the surface of Mars. And when it came out, some of the less reputable newspapers got all excited about the face on Mars. If you look in the object in the sort of top left-hand corner, you can see It's clearly a
rock.
sculpture of a face that somebody has carved on Mars. Amazing. This is a phenomenon that has a rather fancy name that I probably can't pronounce because I didn't do Greek at school, something like pareidolia.
This rock before.
It is the fact that we actually are so good at recognizing the pattern of faces, we see that pattern even when it's not there.
Because
As it happens,
it would
when
be
you
this
look
guy
at a
right here.
better picture of
If
it,
it
this was the
was,
best one that was around at
it'd
the
be
time.
this guy right
Now
here.
we have a much better picture of that same structure. The face pretty much disappears. You can just about see where it was, but it clearly isn't a carving of a face. So patterns
Maybe.
can mislead us
Maybe.
because we see them when they aren't there, but equally, there can be
Well,
a
can you
pattern we
argue that
see,
there's
it's a real
geology
pattern,
under it that
but we
explains it?
misinterpret it.
Well, then absence of
Remember
evidence
what
is not
Simon
evidence
said
of
in
absence.
that book. Science is basically about
Look at it.
getting the best pattern. We have to move on sometimes from our current patterns. And one of the ways a pattern can very easily mislead us, we're all familiar with probably, is the optical illusion. This is my absolute favourite optical illusion
could
in the
be
whole world.
photoelectric
Many of you
effect.
may well have seen it already, but I
need
can't resist it.
one.
And it relies on two patterns.
Gotta
We've
give
got
me
a pattern
one.
of a chessboard, and we've got the pattern of what things look like when there's a shadow. And Ed Edelman, who produced this, Edelson, was able to combine the two to do something rather
You
bizarre.
know the bowl
So there
over
are
in
two
Egypt
squares
there,
on that
that
board,
big, what
labelled
is
A
it?
and B,
Not obsidian, it's
and they are actually both exactly the same
basalt
shade of grey.
tomb. Put that one in there.
No, your brain does not allow you to see that. I've seen this picture thousands of times. I still cannot see them as the same shade of grey, but they are. I'm going to demonstrate that to you. I could be cheating even with this demonstration, but trust me, literally all I'm going to do is take the A and move it to the B. And when I do that, I'm not changing the colour of that A in any way. You will see they are exactly the same shade of grey. But because our brain understands the patterns of chessboards, understands the pattern of shadows and how they appear to work, it fools us. So we've all got to be very careful with patterns. Science is very careful, good science, about making sure it's the right pattern being applied in the right way. Another example of patterns going wrong is superstition.
Well, it depends on what
Superstition
kind of
is
engineer you
essentially
are.
applying a
The
pattern
plasticity would still be right there.
to an
What are
occurrence, but it's the wrong pattern. I suppose a classic example is our reaction to the number
Saw somebody.
13, the fear
Somebody.
of 13, even has a fancy name, back to the Greek again, triskaidekaphobia. Nobody's really quite sure why the number 13 is
You imagine,
associated
see where
with
this is going.
bad luck, certainly in Western parts. It's been said it might be something to do
I could have been talking
with,
about bowl.
the
What do you know?
disciples in the
What
Bible
do
or
where
whatever.
do you see Mason
I think it's
Roma?
much more likely,
No,
actually,
they're definitely stocking.
that there was a pattern of events, a number of events came together when the number 13 linked them together. Bad events. And people thought, ooh, it's
Just
something
night
to
shift,
do with that.
you know, doing
But
one
so
for a
strong
guy.
is this
Just help him out
that
on
when
night
people are
shift.
designing
and
things, they quite often actually
bored.
try to
We're
avoid
down-
the number
I
13.
was bored.
You
Clearly.
heard earlier on, I used to